Hi, my name is Eric Llewellyn, and I work as a system administrator for Hivelocity hosting. And in this video, we're going to learn about Docker. So what is Docker, what makes Docker advantageous, and why you might want to start using it in your environment. So first off, Docker is a tool that allows us to run software in something called a container. And a container is just an isolated environment that has all the requirements for a particular piece of software to run. So think dependencies like PHP or Node.js, and an operating system like Ubuntu, Alma Linux, or something of the sort like that. And down to the left, we have a diagram of a Docker image. And a Docker image is what these containers are deployed from. They're the initial starting off point. And you can see at the bottom, you can see in the overall diagram that we have layers. And at the bottom, we have an operating system layer. And here we have Alpine Linux. And Alpine Linux is a common choice for Docker images because we don't need all of the CLI tools that a fully fledged server operating system would need for an administrator to use. All we need is the bare minimum required to run Ghost at the top. So all we need for our operating system layer in a Docker image is to be able to run the stuff above it. That's all we need and nothing else. And the result is that Docker images are very small in size. They're a lot smaller, far smaller than something like a virtual machine. So looking further up, we can see we have our dependencies in the form of Node.js because that's what Ghost runs as. It runs as a Node.js process. At the top, we have our actual software application that's the entire goal of our container in the first place, which is Ghost in this case. And Docker images are written from something called a Docker file. And a Docker file lists everything that Docker needs to download, like the stuff we have to the left. But it not only does that, it also lists all the steps that Docker needs to do to bring up the software. So this could be create a folder, copy files, assign permissions to a directory so that a user can interface with it. And in the case of Ghost, one of those instructions is going to be initialize this Node.js server process and expose this port so we can access it. So all of this behavior that Docker does means that we don't have to do it manually. And the result is that our deployments become much quicker and they get a lot more consistent. So now we know a bit about what makes Docker special for a sysadmin. But how does Docker help developers, for instance? Well, in the past, whenever a developer wanted to write a server-side application, he would have to write a multitude of different binaries in his releases. So this includes Debian, this includes Red Hat-based installations, and he would have to do a significant amount of work to make it also available on Linux and Windows. And the same goes for Mac OS as well, for like a client-side application. He would have to keep up with all these different ways of deploying his software, and not only that, but keep up with documentation. If you look to the bottom left, or bottom right, you'll see a snippet from Nextcloud's documentation. You'll see all of these different methods of installing it on these different deployments. That documentation takes time, and that documentation has to be updated the same as releases need to be updated. Now, how does Docker help out in this department? With Docker, a developer can write this application and have it be installed on whatever operating system he prefers. Let's say a developer loves Ubuntu Server. He can create a Docker file that will always download Ubuntu Server and bundle his dependencies and ship out the software he knows best. And since you can install the Docker engine onto pretty much any operating system, or at least any operating system you'd want to put on a server, this means that the developer only has to keep up with one deployment method and only has to write documentation for one deployment method. So this is a huge benefit for developers because they get to spend a lot more of their time doing what developer wants to spend most of their time doing, writing code, instead of keeping up with multiple deployments or documentation. And another thing about this is that instead of having to specify separate projects, like say a developer wants to use a reverse proxy or a database in his software, instead of writing out documentation on, oh, here's how you install Nginx or install a database to work with my software, he can just include that as a separate container to be used in conjunction with his in a Docker deployment, such as Docker Compose or Docker Run. And this means that a lot of the work for a developer is spent less on packaging the code and more on writing the code, which is the ideal situation. Another way we can learn a lot more about Docker and containers is to compare them to something we already know a fair deal about, which is a virtual machine. Moving down here, you'll see I've drawn an illustration of a couple deployment stacks. One is containerization and one is virtualization. So with Docker to the left, what we do is we install a non-hypervisor operating system like Ubuntu Server or Alma Linux onto our physical server, and then we install Docker Engine. And Docker is the thing that allocates our resources and separates our processes via containers. And looking at the right, we have a hypervisor like ESXi, Proxmox, or Hyper-V, and then we have the virtualized hardware layer. And this is where we take the machine part in a virtual machine and we virtualize something like CPU cores, a network interface card, or a storage device. And none of this takes place on the left here in Docker. But another neat thing about Docker is that you can still get most of the benefits of Docker while taking advantage of virtualization. Let's say maybe we want a firewall to be separate from our host operating system in Docker. This could be for security reasons. And what we can do is we can take Docker and we can run it in a virtual machine. And this right here can be our Docker host operating system. And then over here can be our firewall operating system that can contain our firewall. This could be pfSense or OpenSense or possibly VSRX. And what we're able to do here is if we have a physical server with 192 gigs of RAM per se, we can give 8 to the firewall, because that's normally what a firewall will need, if even that. And then we can give 180 to our Docker host, 180 gigs of RAM, and it can take better advantage of all those resources than if we split it all into a bunch of different virtual machines. And what I mean by that is down here, where I have a few different illustrations of bubbles with Docker and then boxes with a virtual machine. And the reason why the virtual machine is a bunch of boxes is because these are static. We assign them when we create the virtual machine, and it doesn't change unless we shut down the virtual machine and then change these resources and bring the virtual machine back up. But that process involves downtime, and it's also not automatic. We, as a sysadmin, would have to do it ourselves or connect it to an API to do it for us. But that's a separate thing we would have to set up. It's not automatic like it is with Docker. But the key thing to take home here is that if this is a virtual machine and it is using 8 gigs of RAM and 2 virtual CPUs, as in CPU threads, the problem is that the other 2 CPU threads and 8 gigabytes of RAM are essentially wasted. The rest of the machine can't take advantage of that. And this is not the case with Docker, because with Docker we're using containers to separate our processes. And the cool thing about containers is that containers are dynamic. A container is only going to use the amount of CPU percentage or RAM that it needs to run that particular process. And let's say this right here is a WordPress website that normally doesn't get much traffic at all, so it only uses 200 megabytes of RAM. And suddenly the traffic spikes. We get a bunch of people visiting our website, and our container bloats up and is now using, say, 1 gigabyte of RAM. That can happen in Docker automatically without us having to intervene. And this could be hundreds of different containers that are all sitting here using the vast majority of the resources on our physical machine. And we can have Docker manage this, and we don't have to worry about wasting resources because we split them up wrong when we were trying to think about how to divvy it up when we create all of our virtual machines. So that's one thing that Docker makes very efficient when it comes to managing our resources in a hosting environment. So that's a little bit about how Docker works as far as resources go. But what about what a Docker service typically looks like? Well, this is what a WordPress or Ghost deployment looks like in terms of how it works between Docker and the operating system and then exposing the services to the internet. And for WordPress, we would have a database, we would have a web application, this is WordPress itself, and then you have a reverse proxy, this could be Apache or Nginx, that actually exposes it to the internet with SSL and a certificate. And the green connections are, you can think of those as private connections. They only expose something called the container port, and this means that the database can only talk to web application and nothing else. And the reverse proxy, the only container it can talk to is the web application and nothing else. But this dark green line, this is the public connections. This is where the reverse proxy can expose its ports to the host ports and actually expose services to the internet. And that's a rough view of the network flow of what a typical Docker deployment looks like. But what about this purple right here? Well, the purple is a volume, and a volume is how Docker manages persistent data. So if I don't have a volume and I bring this entire service down for a WordPress website, even if I've made a bunch of changes, if I do docker kill and then docker rm, if I run those commands on these containers and then I bring the service back up, everything's going to be gone. It's going to be the default site again, unless I have a volume. Because Docker and containers in general are something that's called stateless, which means that the user data or persistent storage you'd see in a database is decoupled from the application itself. And there's a list of benefits to this, but for now, one of them is just that it makes deployments a lot more modular. You don't have to worry about breaking stuff for your data if you just want to make a quick update to the web application. It's not directly tied to our storage. The only thing that's directly tied to our storage is our database. But let's say for a typical example, I have a friend and I spun this entire website up in Docker for my friend. It's a WordPress website. And then I get another server that I want to move all my stuff to. And that server happens to be Alma Linux. Well, it's Docker. I can install Docker Engine on any well-known server distribution that exists. So if I want to go to Alma Linux, right here, not a problem. And this is my friend's website. But let's say I have 3 more friends. I suddenly gain 3 more friends, and they hear that I'm a sysadmin, so they all want their own website too. I can copy the same deployment, specify a new volume, and spin 3 more services up in Docker. And I can also use the same container I had before as a reverse proxy. So I can keep this mapping with the host as far as exposing 80 and 443 goes. And I can define all of my domains and information in the reverse proxy, which could be Traefik or Nginx, and manage all of this within Docker to the point where I've got everything about multiple services defined in Docker YAML files and a few volumes, which means I can take this entire stack if I wanted to, and I could copy it somewhere else to a different server, just like I did with that first deployment. And this is what people mean when they say that Docker is modular. No, not modular. My apologies. This is what people mean when they say Docker is portable. I can take a huge, complex service, and within Docker, I can copy it to any other host I want to. And this is really a superpower when you have to do migrations, and it makes life a lot easier when it comes to managing your deployments. So that is my take on Docker for you, and I hope you learned something, and thank you for watching.